What if your eye color is more than just a physical trait? What if every time you look in the mirror, you're actually seeing a record of thousands of years of human survival, migration, and evolution? Most people think eye color is simply a matter of appearance. Brown, blue, green, gray, just another feature inherited from their parents. But scientists have discovered that eye color tells a far deeper story. It contains clues about where your ancestors lived, the environments they faced, and the genetic changes that helped them survive. Today, more than 70% of the world's population has brown eyes. This isn't a coincidence. Brown eyes provided important advantages for early humans living under intense sunlight, helping protect their vision from harmful ultraviolet radiation. But not everyone shares this ancient trait. The remaining eye colors blue, gray, green, hazel, amber, and even rare conditions like heterochromia exist because of remarkable genetic mutations that appeared throughout human history. Some of these mutations emerged only a few thousand years ago. One of them may have originated from a single individual who lived between 6,000 and 10,000 years ago. Yet today, millions of people around the world carry that genetic legacy. In this video, we'll uncover the fascinating science behind every major eye color and reveal how your eyes may hold the story of your ancestors' journey across continents, climates, and generations. By the end, you may never look at your own reflection the same way again. If eye color is a record of human evolution, then brown eyes represent the original chapter of that story. Long before blue, green, or gray eyes appeared, nearly every human on Earth had brown eyes. This wasn't an accident. It was one of the most successful survival adaptations our species ever developed. The secret lies in a pigment called melanin. Brown eyes contain large amounts of this remarkable substance, which acts like a natural shield built directly into the iris. Melanin absorbs a significant portion of incoming light before it can penetrate deeper into the eye. More importantly, it helps block harmful ultraviolet radiation that can damage delicate eye tissues over time. For early humans living in Africa, where intense sunlight and high UV exposure were constant challenges, this protection was critical. Every day spent hunting, gathering, and traveling under the open sky exposed the eyes to powerful solar radiation. Individuals with higher melanin levels had a natural advantage, helping preserve vision and reduce the harmful effects of prolonged sun exposure. Brown eyes also offer another benefit: reduced glare. Because melanin absorbs light rather than scattering it, people with brown eyes often experience less visual discomfort in bright environments. This can improve visual clarity during daylight and make it easier to function under strong sunlight. These advantages help explain why brown eyes remain the dominant eye color today. As humans expanded across continents, populations living closer to the equator continued to benefit from strong UV protection. Even now, more than 70% of the world's population has brown eyes, making them by far the most common eye color on Earth. Far from being ordinary, brown eyes are a living reminder of humanity's earliest struggle for survival. They carry the genetic legacy of countless generations who adapted to some of the harshest environmental conditions our ancestors ever faced. If brown eyes represent humanity's original design, blue eyes tell the story of one of the most remarkable genetic changes in human history. Scientists believe that every person with blue eyes alive today can trace this trait back to a single common ancestor who lived between 6,000 and 10,000 years ago. Before that mutation appeared, every human on Earth likely had brown eyes. The change is linked to a genetic variation involving the HERC2 gene, which affects the production of melanin in the iris. Rather than creating a new blue pigment, the mutation simply reduced the amount of melanin present in the eye. This leads to an astonishing fact: blue eyes are not actually blue. Unlike brown eyes, blue eyes contain very little pigment. When light enters the iris, shorter blue wavelengths scatter back toward the observer, while longer wavelengths pass deeper into the eye. This phenomenon, known as light scattering, is similar to the process that makes the sky appear blue. As a result, blue eyes can seem to change shade depending on lighting conditions, sometimes appearing bright blue, gray, or even icy silver. What fascinates researchers most is how quickly this mutation spread. Within a relatively short period of human history, blue eyes became extremely common in parts of Northern Europe. In some regions, their frequency eventually reached over 70% of the population. Why did this happen? Scientists continue to debate the answer. One theory suggests that reduced melanin allowed more light to enter the eye, offering an advantage during the long, dark winters of northern latitudes. Another hypothesis points to sexual selection. Because blue eyes were rare and visually striking, they may have become desirable traits that were passed on more frequently through mate choice. Whatever the reason, blue eyes remain one of the clearest examples of how a single genetic mutation can reshape human populations and leave a lasting mark on the story of our species. Gray eyes are among the rarest eye colors in the world, found in less than 3% of the global population. Although they are often mistaken for blue eyes, gray eyes are genetically and physically distinct. In fact, they typically contain even less melanin than blue eyes, creating a unique interaction with light that gives them their characteristic silver, steel, or smoky appearance. Unlike blue eyes, which primarily scatter shorter blue wavelengths, gray eyes disperse light across a broader range of wavelengths. This creates a more neutral and stable color that can appear silver in bright conditions and darker slate gray under cloudy skies. The effect is subtle but striking, giving gray eyes an appearance that many people describe as mysterious or intense. Scientists believe gray eyes may have evolved as an adaptation to regions with limited sunlight, particularly parts of northern and eastern Europe. In environments where long winters, overcast weather, and reduced daylight were common, lower melanin levels may have allowed more light to reach the retina, potentially improving vision in dim conditions. However, this adaptation came with a trade-off. Because melanin also helps protect the eyes from ultraviolet radiation, people with gray eyes generally have less natural protection against UV exposure than those with darker eyes. As a result, they may be more vulnerable to long-term damage caused by excessive sunlight. Today, gray eyes remain one of the most unusual and fascinating examples of how human populations adapted to different environments throughout history. Green eyes are one of the rarest and most fascinating eye colors on Earth. Only about 2% of the global population has naturally green eyes, making them even less common than blue eyes. Their rarity is not the result of a single genetic mutation, but rather a remarkably complex combination of inherited traits. Scientists believe that at least 16 different genes contribute to eye color, and green eyes emerge only when several of these genes interact in just the right way. Unlike brown eyes, which contain high levels of melanin, or blue eyes, which contain very little, green eyes occupy a delicate middle ground. They contain moderate amounts of melanin combined with a yellowish pigment known as lipochrome. When light interacts with this unique mixture, the result is the distinctive green appearance that has fascinated people for centuries. One of the most intriguing characteristics of green eyes is their ability to appear different under changing lighting conditions. In bright sunlight, they may look vivid emerald or golden green. In shadow, they can appear darker, softer, or even slightly gray. This shifting appearance is not due to changing pigment, but rather the way light reflects and scatters through the layers of the iris. Because of their rarity and dynamic appearance, green eyes have played a prominent role in folklore and mythology throughout history. In medieval Europe, they were sometimes associated with mystery, magic, and supernatural abilities. In other cultures, green eyes were linked to intuition, creativity, and unique insight. These beliefs may have emerged simply because green eyes were uncommon enough to stand out from the crowd. From an evolutionary perspective, green eyes may represent a balance between the advantages of dark and light eyes. Their moderate melanin levels provide some protection from ultraviolet radiation while still allowing relatively high light sensitivity. Today, green eyes remain one of the most striking examples of how complex genetics, environmental adaptation, and human history can combine to create extraordinary diversity within our species. If green eyes are rare, hazel eyes may be the most unpredictable of all. Often described as the chameleons of the eye color world, hazel eyes have an extraordinary ability to appear different depending on the environment. In one setting, they may look green, in another golden, and under different lighting, they can appear almost brown. This remarkable flexibility makes hazel eyes one of the most dynamic and visually fascinating traits found in humans. The secret behind hazel eyes lies in their intermediate melanin levels. They contain more melanin than blue or green eyes, but less than brown eyes. Combined with varying amounts of lipochrome, this creates a complex structure that interacts with light in unique ways. As light conditions change, different colors become more prominent, giving the impression that the eyes are changing color. From an evolutionary perspective, hazel eyes may represent a highly adaptable balance between dark and light eye colors. Their moderate melanin content provides a reasonable level of protection from ultraviolet radiation while still allowing good light sensitivity. This combination may have been particularly useful in regions with changing seasons, mixed climates, and highly variable lighting conditions. Hazel eyes also reflect extraordinary genetic diversity. Unlike some eye colors that can often be traced to specific genetic patterns, hazel eyes result from a wide range of gene combinations. This is why two people with hazel eyes can look completely different. One person may have green-dominant hazel eyes with golden flecks, while another may display mostly brown tones surrounded by green rings. Today, hazel eyes remain a striking example of how human genetics can produce incredible variation. They stand between the extremes of dark and light eye colors, combining adaptability, diversity, and visual complexity in a way that few other traits can match. Among the rarest eye colors in the world, amber eyes and so-called black eyes represent two fascinating extremes of human eye pigmentation. Although they appear very different, both reveal how variations in pigment helped humans adapt to different environments over thousands of years. Amber eyes are exceptionally uncommon and are often mistaken for hazel or light brown eyes. However, true amber eyes possess a distinctive golden, copper, or honey-colored appearance that remains relatively stable under different lighting conditions. This unique color comes largely from a pigment called lipochrome, which is present in higher concentrations than in most other eye colors. Unlike hazel eyes, which can shift dramatically between green, gold, and brown, amber eyes tend to maintain their rich golden tone. Their striking appearance has often been associated with alertness, intensity, and confidence throughout history. At the opposite end of the spectrum are what many people call black eyes. In reality, true black eyes do not exist. What appears black is actually an extremely dark shade of brown, caused by very high concentrations of melanin. This dense pigmentation absorbs most incoming light, making the iris appear almost completely black under normal conditions. From an evolutionary perspective, these very dark eyes offer significant advantages. High melanin levels help protect delicate eye tissues from ultraviolet radiation and reduce glare in bright environments. This protection would have been particularly valuable in regions with intense sunlight and long-term UV exposure. Today, very dark brown eyes are especially common in Africa, South Asia, Southeast Asia, and many equatorial regions where strong sunlight remains a constant environmental factor. Amber eyes, meanwhile, are found much less frequently and appear in various populations across Europe, Asia, and South America. Together, amber and dark brown eyes demonstrate two very different solutions to the same evolutionary challenge: adapting human vision to a constantly changing world while preserving one of our most important senses. Among all eye color variations, few are as striking as heterochromia. This rare condition occurs when a person has two different eye colors or multiple distinct colors within the same iris. One eye may be blue while the other is brown, or a single eye may contain sections of different colors. Because it breaks the visual symmetry that humans naturally expect, heterochromia often attracts immediate attention. Despite its dramatic appearance, heterochromia is extremely uncommon, affecting less than 1% of the world's population. In most cases, it is harmless and simply reflects unique genetic patterns that developed before birth. During normal development, melanin is distributed relatively evenly across both irises. Heterochromia occurs when this process is altered, resulting in different amounts of pigment being deposited in each eye or in specific regions of an iris. The condition can arise from genetic mutations, mosaicism, or other developmental variations that affect pigment production. In many individuals, it is present from birth and remains unchanged throughout life. Because of its rarity, heterochromia has inspired countless myths and legends throughout history. In some cultures, people with two different eye colors were believed to possess special powers, heightened intuition, or a connection to the spiritual world. Others viewed it as a symbol of duality, representing two different perspectives existing within the same person. Today, science explains heterochromia as a fascinating example of human genetic diversity. Rather than being mysterious or supernatural, it serves as a reminder that even small variations in our DNA can produce extraordinary and beautiful differences among people. As we reach the end of this journey, one thing becomes clear. Eye color is far more than a cosmetic feature. It is a living record of human history, carrying clues about the environments our ancestors faced, the challenges they overcame, and the genetic adaptations that helped them survive. Brown eyes tell the story of humanity's earliest origins under intense sunlight, where high levels of melanin provided critical protection from ultraviolet radiation. Blue eyes reveal a remarkable genetic mutation that spread across Europe and changed the appearance of entire populations. Gray eyes reflect adaptation to dim northern environments, while green eyes demonstrate the delicate balance of multiple genes working together to create one of the rarest colors on Earth. Hazel eyes showcase extraordinary flexibility and diversity, while amber and dark brown eyes represent different solutions to the same evolutionary challenge. Even heterochromia reminds us that small variations in our DNA can create extraordinary uniqueness. Together, these eye colors map the migrations of our ancestors across continents and through thousands of years of changing climates. Every shade reflects a chapter in the story of human adaptation. From the African savanna to the forests of Europe and beyond, our eyes carry traces of where we came from and how we survived. So the next time you look in the mirror, remember that you're seeing more than a color. You're seeing the result of countless generations, millions of choices made by nature, and an evolutionary journey that spans thousands of years. If you enjoyed this exploration into the science of eye color and human evolution, be sure to like the video, subscribe to the channel, and share it with someone who has ever wondered what their eyes might reveal about their ancient past.